Alright, guys, welcome to the session, and I hope all of you guys are doing good. So let's get started with today's session. So we are finally starting this journey of data analytics with generative AI, and we are starting with the first topic, that is statistics. Statistics is again very important concept when we are getting and playing around with the data sets. So statistics को समझना और understand करना is very important. And as we are dealing with the data, so you will be playing with a lot of statistical terms. By just seeing the statistical values which we are going to learn, you will get an idea how the data is, what the data is, and what type of distribution it has, and various other details, right? So it's an important concept. We must have studied that in our school days. So why we are starting with statistics? Just to revise the things so that when we'll start with playing the data, and when I will be talking about these terms, then it should not be alien for you guys, right? So we'll understand from basics, we'll understand and we'll try to solve various questions as well to make sure that our understanding on these terms, which are specifically for the data analysis point of view, you should be clear with that. Okay. So let's start with this. So first of all, what is statistics, or I can say the introduction of statistics. Now, statistics is the science of learning from data. It helps us collect, understand, and make decisions using data. Think of this like statistics is the GPS for decision making using numbers. We use statistics every day. For example, we can check the average marks in the class. We look at the weather forecast when a company wants to know what customers like, when doctors want to know how a medicine works. तो हमारे स्टैटिस्टिक्स का जो यूसेज है वो हर जगह हमारे डेटा एनालिसिस में होने वाला है, राइट? वेदर यू विल बी वर्किंग एज अ डेटा एनालिस्ट, और यू आर वर्किंग एज अ मशीन लर्निंग इंजीनियर, or you are working as a AI engineer, or you are working as a data scientist, right? And we know that there is a huge amount of requirement going on in this data fields. And as I mentioned, right, this is like high opportunity jobs which we have in the market. So our aim is here to make sure that you guys are very much confident on these terms, so that once you will be appearing for the interviews, you will be able to crack it easily as well. So statistics is, like, as I mentioned earlier as well, it's very important concept. And you will see that quite extensively over the period of time when we will be solving some real-time problem statements. Now, types of data. So as we are working as a data analyst, you will be getting certain types of data, right? So data are of two major types. अगर मुझे डेटा को कैटेगराइज करना है तो मेरे पास दो मेजर टाइप्स हैं डेटा के. One is your qualitative data. Second is your quantitative data, right? In qualitative data, I have further three parts. But before I get into that, what is qualitative data? Qualitative data is also, you can say it as categorical data, or you can also call it as dimensions, or qualitative data, right? So qualitative data तीन अलग अलग नाम से जाने जाते हैं. उसको तुम categorical data भी बोल सकते हो. You can call it as dimensions as well, या तुम उसको qualitative data भी बोल सकते हो. It's like a category. Second is the quantitative data. Quantitative data is what? इसका दूसरा नाम है न्यूमेरिकल डेटा. or you can call it as a measure, or you can call it as a facts, right? सो कोई बोले तुम्हें कि मेरे पास ये सारे फैक्ट्स हैं, दैट मीन्स इट्स बेसिकली टॉकिंग अबाउट द न्यूमेरिकल डेटा. इफ समवन विल से दैट मेरे पास न्यूमेरिकल डेटा है, दैट मीन्स इट्स टॉकिंग अबाउट द क्वांटिटेटिव डेटा. इफ दे आर सेइंग आई हैव सम मेजर्स, दैट मीन्स इट्स टॉकिंग अबाउट क्वांटिटेटिव डेटा, राइट? तो ये अलग अलग नाम है. क्वांटिटेटिव इज ऑल्सो न्यूमेरिकल और मेजर और फैक्ट्स एक ही बात है. नाउ qualitative data are of three further types. One is your nominal, second is your ordinal, and third is your boolean. Now what it means and what type of data it actually has, right? So let's talk about nominal. For example, let's say I have state. In state, let's say I have Gujarat, Haryana, Maharashtra, and so on, right? So now here Gujarat is one category, Haryana is one category, Maharashtra is one category, right? I cannot say कि गुजरात हरियाणा से बड़ा है, या I cannot say हरियाणा महाराष्ट्र से बड़ा है, right? I cannot say that. Or let's say gender. In gender I have male or female. So I cannot say that male is bigger than female or female is bigger than male. I cannot say that, right? It's individual categories. So nominal data is basically nothing but nominal data is a pure category where I cannot say that you are bigger or I am bigger, right? State हो गया, city हो गया, gender हो गया, region हो गया, category हो गया, department हो गया. I cannot say that IT department is bigger than HR department. No, it's not like that. So basically in any data where I don't basically say that one is bigger than smaller or something like that, that is your nominal. Second is your ordinal. Ordinal is basically nothing but it has some order, right? It has some order to it. For example, you are giving feedback to this class. Now the feedback could be poor, feedback could be average, feedback could be good, or feedback could be excellent. Now here I can very well say that poor is lesser than average, average is lesser than good, and good is lesser than excellent, right? So it has order to it, right? It has order to it. So this type of data is known as ordinal data, where we have certain order. Next is the Boolean. Boolean is more like true and false, yes or no type of concept. For example, are you graduate? So you will say either yes or you will say either no. Are you married? You will say either yes or you will say either no. So it's like yes or no type of data. That is your Boolean data, right? That is about your categorical information. If I come to this, right, quantitative. In quantitative, we have two types of numbers. One is discrete numbers. Second is the continuous numbers. Discrete number is nothing but a number without decimal, right? Number without decimal. For example, let's say I want 5 pens. I cannot say I want 5.5 pence, right? So a number without decimal is discrete, something like quantity of your product. I want to purchase one TV, two fridge, or something like that. Continuous data is nothing but a number with decimal, right? A number with decimal. That means what? Something like I want 5.5 liters of milk, right? Or I want 5.75 liters of petrol. Or I have a salary. My salary is, let's say, 10,000.25 rupees. So decimal is there, right? So that is my continuous data. So broadly, your data will always be in this section. It will be falling in this only, right? Think of any business. Apart from date we are not considering as of now. Apart from date, if you see any data, you will be getting this type of data only. It will be having some category, it will be having some ordinal data, it will be having some booleans data, it will be having some discrete values, it will be having some continuous values. Apart from that, you will not gonna get any other type of data, right? So that is the different types of data which you will mostly going to deal with as a data analyst point of view. Now, statistics are of two major types. For data analysis point of view, we are good to understand the descriptive statistics, right? Statistics are of two major types. One is your descriptive statistics. Second is your inferential statistics. So we will be focusing more on descriptive statistics, and we will be introducing the understanding of inferential statistics as well. But now, what is descriptive statistics? Whatever data I have, I want to get the insights from that data. I want to get some interesting numbers from that data, right? That is the requirement. So descriptive statistics is like a summary or a quick snapshot of a bunch of numbers, that is data, so that it is easier to understand what's going on. For example, imagine you have marks of 100 students in a math test. If I show you all 100 numbers, it's too much to look at. But what if I told you the average marks is 76, highest marks is 98, lowest marks is 45, and most of the students scored between 70 and 80. That is descriptive statistics, right? So rather than me checking the individual data point, I am giving you a summary of my data, that this is the average, this is the median, and so on and so forth. So that is basically giving me the information, right? That is giving me the information that how the data is. So now let's go ahead and let's try to understand this with some more example. Before I get into some of the numbers out here, I'll take one sample data set. So let's say this is my data set, which I have. Now it has a lot of information, right? As of now, just try to understand that we have this data set and it consists of a lot of information, right? It's a big data. It's have around 1,000 records, or I think 9,000 records, right? So it's a big data. It's a data of a retail store, right? It's talking about what is the order ID, what is the order date, on which date the shipping happened, what is the ship mode, what is the customer ID, what is the customer name, what is the segment on which he purchased the product, what is the country or region, what is the city, what is the state, what is the postal code, what is the region, what is the product ID, what is the category, subcategory, product name, sales, quantity, discount, and profit, right? So a lot of things are there, but as of now, I will be focusing on the sales column, right? Let's focus on the sales column. Now, by just seeing these sales numbers, by just seeing these entire big sales numbers, can I get any information just by seeing the numbers? The answer is no, right? It's not making sense as of now. I have a lot of numbers out here, but what this number means, what is the information I am getting from these numbers? As of now, I am not sure about that. Then what will I do? I am trying to get some interesting information from this data. The interesting information which I want from this data is what? One is, what is the mean, right? We'll understand what mean is, but basically, what is the mean I want to find out. Second, what is the median? As of now, let's talk about these two numbers. Mean is basically nothing but average, right? I want to get the average. Now, average is basically nothing but, it's like sum of all the values divided by number of records. In Excel, we have one formula called average. So I'm using that. I am choosing the entire columns and pressing enter. The average is coming out to be 228.2. Now, what does that mean? It means that the average sales happened is 228.2. You can see that some of the sales happened is $3, $16, $31, $609, $2,500. But what is the average? The average is nothing but, on an average, people are purchasing at least this much of sales, right? This much of sales is happening per person, right? Some could be less, some could be more, but on an average, this is what you are getting. On a simple note, let's say we gave an exam and we got some marks out of 100, right? Let's say I have 25 marks, 34 marks, 56 marks, 87 marks, 90 marks, and let's say 45 marks. So what is the average? What is the average marks? Average marks is nothing but sum of all the values. Let me sum it up. This plus this plus this plus this plus this plus this. This is the total marks which I got. How many learners are there? 1, 2, 3, 4, 5, 6. 6 learners are there. So basically, 337 divided by 6, that is 56.16. So the average marks of the class is 56. That means on an average, learners are getting 56 marks. Some could be lesser, some could be higher, but average is 56, right? So one of the measures in the descriptive statistics is known as measure of central tendency. Measure of central tendency is basically nothing but, it is giving me an understanding about what is the center number, right? What is the center number? That means there are 3 measure of central tendencies. One is mean, second is median, third is mode, right? So measure of central tendency helps us to find the center of the middle of a set of numbers. It tells us what a typical value looks like in our data. There are 3 main measures. One is mean, second is median, and third is the mode. Now, why do we use it? When you have a bunch of numbers, it's hard to make sense of them all at once. So instead of looking at every number, we find one number that represents the whole group. So basically, it is giving me the understanding of the entire group, how the things are, right? So on an average, 56 is what we got in the marks. And we are using this average quite extensively in our day-to-day work as well, right? When you are, let's say, purchasing a car, you ask what is the mileage. Mileage is what? Mileage is average, right? Average कितना देता है? So average is like very important number for us to understand. It has some limitations as well, which I will discuss, but it's very important number. क्लास का एवरेज मार्क्स कितना है? एवरेज सैलरी कितनी है अपने कंपनी में, राइट? एवरेज हाइट कितनी है इंडियंस की? एवरेज वेट कितना है? सो ऑल दोस थिंग्स आर इंपॉर्टेंट नंबर्स फॉर अस. So average is basically nothing but, we'll talk about more in detail. So average is basically nothing but, this is the formula. Mean is nothing but the average. Add up all the numbers and divide by how many numbers are there. That is your average, right? Formula is simple. Mean is nothing but 1 upon n. N is nothing but total number of records. So 1 upon n summation of xi. Xi is nothing but your individual records, right? Xi is nothing but your individual records. Let's see this. These are the numbers for 5 tests. So 70 plus 75 plus 80 plus 85 plus 90 divided by 5. So summation of xi, that means I am summing all my xi's, and then I am dividing that with n, 1 by n. 5 tests, right? So divide by 5. So basically, this is my average. So I want you guys to calculate the average for the same. What do you think is the average is? As per me, it should be 80. Right? Perfect. All right. So let's proceed now. So average is basically one of the numbers which is giving me some information about the data. Although it's not giving me the entire information about the data, but it is giving me a decent information about the data. Now, next is the median. Now, what is median? Median is also one of the measure of central tendencies, right? There are 3 measure of central tendency: mean, median, and mode. So the second one is your this thing, median. Now, median is what? The number in the middle when all the numbers are arranged in an order. That means if I go back to this Excel example, the first thing is I will have to sort this data, right? Data should be sorted, right? Data should be sorted. So here 25, 34, 45, your 80, 56, 56, 87 and 90. My data is sorted, right? This sorting can be anything, right? Your sorting can be ascending also, sorting can be descending also. That's okay. So here you can see the data is sorting ascending. Ascending means छोटे से बड़ा. Okay, छोटे से बड़ा sorted. Now once the data is sorted, what is the middle value? How many values are there? 1, 2, 3, 4, 5, 6 values are there. 1, 2, 3, 4, 5, 6 values are there. What is the middle value? Middle value is nothing but there are two middle values because it's an even number. It's an even number. 1, 2, 3, 4, 5, 6. It's an even number, right? So middle two value, what is the average of that? 45 plus 56, 101 divided by 2, 50.5. So my median will be 50.5, right? That is the median for us. So here you can see that when you are having the even numbers, this is the formula. When you are having the odd numbers, this is the formula. Let's try to understand this formula. Suppose we have 6 numbers. So n is 6. N is 6. Median for odd number, you have to use this formula. Median for even number, you have to use this formula. I have even numbers, so I have to use this formula, right? So 6 by 2, that is n by 2, plus 6 by 2 plus 1 upon 2. 6 by 2 is what? 3. Plus 3 plus 1, 4 by 2. That is 4, 7 by 2. Let's come back to your data set, right? N is actually nothing but the number of that data set. So let's go to the Excel. Right? This is my Excel. Let me sort the data first. 25, 34, 45, 56, 87 and 90. So 1, 2, 3, 4, 5, 6 numbers are there. Now what is my n by 2? As per the formula, if you see here, n by 2, n is nothing but 6. There are 6 numbers, right? So out of this 6 numbers, n by 2 is 3. So 3 is nothing but this number, right? N by 2 is what? 6 by 2, that is 3. So third number, first number, second number, third number, fourth number, fifth number, sixth number. So this is the number. Then the formula was n plus 1, n by 2 plus 1, right? So n by 2, that is this 3, 3 plus 1, that is 4. That means this number, 56. So 45 plus 56. 45 plus 56 divided by 2. That is 101 by 2. That is 50.5, right? That is 50.5. So 101 by 2, that is 50.5. Okay. So that is the median when you are having even numbers. When you are having odd numbers, for example, let's say 90 is not there. So we have 25, 34, 45, 56 and 87. Data is sorted. The middle value is 45. That is the median. But as per the formula, what it is? N plus 1 by 2. What is n? N is nothing but 1, 2, 3, 4, 5. So 5 plus 1. 5 plus 1 by 2. That is 3. So 1, 2, 3, 45. So 45 is your median, right? So that is the formula for my median that we use. Are you guys clear with this, all of you? Till this point, what we have discussed? Median is also known as 50th percentile, right? Median is also known as 50th percentile. So when someone says that 50th percentile is 56, that means median is 56. That you have to understand. Okay. So another name for median is 56. Sorry, another name for median is 50th percentile. Next is the mode. Now what is mode? Mode is nothing but most frequent number. So if you see here in my data set, the number that appears most often, 20, 22, 22, 23, 25. So out of these 5 numbers, 22 is coming quite frequently. So in my example, 22 is my mode in this particular data set. There can be a chance that you may have more numbers, right? For example, let's say I am having data something like this. 21, 22, 22, 22, 23, 23, 23, 24, 24, 25. Now in this case, 22 is coming 3 times and 23 is also coming 3 times. So basically we have 2 modes. One is 22 and 23. This type of data is known as bimodal data, right? We have 2 modes, bimodal data. If there are 3 modes, that will be a trimodal data. If there are more than 3 modes, it is known as multimodal data, right? So here you can see that trimodal, bimodal, and we have more than 3, it's multimodal. If there is no repetitive values, in that case, there is no mode, right? Let's say all the values are coming one time only. So in that case, there is no frequency, no multiple values. In that case, I can say there is no mode data. Okay. So here is the summary for these 3 numbers, which is also known as measure of central tendency. Measure of central tendency is basically which is giving me the center number, right? Mean, median, and mode. Mean is nothing but the average value. Values are closer together. I'll discuss about that later on. Don't worry about that. The middle value is the median, and the most frequent value is the mode, right? So that is your 3 numbers which we have discussed. Average is the mean, middle value is the median, and mode is the most frequent. When to use this, we'll discuss that in some time. Now, this picture is very important. Let's spend some time here and let's try to understand. I'll take few data sets and we'll try to understand, right, what and how it is. So let's go to Excel and let's try to understand. Let's say I have class 1 marks, right? I have class 2 marks and I have class 3 marks. Okay. Try to understand the behavior of this data, and this is very much you should be aware of. Let's say class 1. The marks is between 0 to 100, right? So let's say the guy got 10 marks, 20 marks, 30 marks, 40 marks, 50 marks, 60 marks, 70 marks, 80 marks, 90 marks, and 100 marks. These are the learners who got these marks, right? There are 10 learners and all got these marks, 10, 20, 30 up till 100. Class 2. In class 2, what happens was, this is the marks distribution: 10, 10, 10, 20, 20, 30, 30, 30, 90, 100. This is the marks which class 2 people got. That is the scenario number 2. Let's come to class number 3. 10, or I can say 0, 10, 85, 85, 85, 90, 90, 95, 95, and 100. Okay. So this is my class 1, this is my class 2, and this is my class 3. Now let me calculate the mean for the same, that is average. Let me calculate the median for the same, that is middle number, and let me calculate the mode for the same as well, all the 3 classes. So let me calculate first the mode. Do we have any function in Excel? Looks like yes. Mode. Let's pass. You can see that here there is no mode. No modal data, right? Or let's make this number as 10 so that we can have the mode. Okay. So this is my mode 10. Or maybe I can make this as 20. Let me have 50. 50 as a mode. Okay. Let's take that. Let's go to this class. Now in this class, what is the mode? Let's go and check. Mode of class 2, and my mode is coming out to be 10. Okay. So my mode is coming out to be 10. And the third scenario is, what about 30? 30 also, it's a bimodal data. So 30 can be also the mode, right? But as of now, Excel is giving 10. So let's go with that. But yes, 30 is also mode, right? Because we have 3 entries there also. And this mode, which we have for the third record, that is coming out to be 85. Okay. So this is the mode for me. Now let's get into your median. Median. Let's pass on this information. My median is coming out to be 50 as well. My median is coming out to be 50 as well. What about here? Median. My median is coming out to be 25. And what about this? Median. My median is coming out to be 87.5. Okay. This is my median. Now let's calculate the mean or average basically. Average is 54. Average is 35. Average is 73.5. Okay. These are the 3 numbers which we got. Now try to understand this. If you see this particular data set, right? In this particular data set, the values are ranging from 10 to 100, right? It's a variety of data. And one thing you will notice here is that the mean, the median, and the mode are on the same line, almost nearby, right? Now let me go back to this picture. Can I say that this is what I am talking about as of now? Your mean, median, and mode are of same type, almost of same type, right? Around 50s. So basically, by seeing that data, by seeing this data, I can clearly say that this data is distributed something like this. Let's check it out. Let's use Python for now. Let me open Jupyter Notebook. We'll understand Python later on, but as of now, just I'll show you the plot. So here is my Python instance, and let me go to my Excel file. Let me copy this data. Don't worry about this, all these codes. We'll discuss that later on. So here you can see, right? See this curve. You are getting this curve. This almost looking like this. What you can see in the PPT. This one. Right? Let's go to the second one. In this, what is happening? In the second data. Here you can see that median and mode are in the lower side. Median and mode are in the lower side. Mean is bit of a higher side. Now, why mean is increasing? Because you can see that these two guys are having the highest marks. And because of that, my overall average increased. Right? Because of this, my overall average increased. These are outliers. Outliers are nothing but very rare in number. फॉर एग्जाम्पल लेट्स से हम क्लास में एग्जाम दिए, सबका मार्क्स अराउंड 30 या 40 आया, बट एक दो लर्नर के 90 100 आ गए. तो पूरी क्लास में से वो दोनों बहुत अलग टाइप के बंदे थे जिनका बहुत ज्यादा नंबर आया, तो उनको हम बोलेंगे आउटलायर्स. ये एग्जाम्पल रियल टाइम लेते हैं. लेट्स से आई एम वर्किंग फॉर इंश्योरेंस इंडस्ट्री. मेरे पास सारे के सारे पेशेंट्स का एज जो कि कस्टमर्स हैं अराउंड 20 to 50 ईयर्स पे है, बट कुछ कस्टमर्स मेरे 90 ईयर्स वाले हैं. तो 90 ईयर्स वाले कस्टमर कौन होंगे? वो मेरे आउटलायर्स होंगे. राइट? सो आउटलायर्स आर नथिंग बट विच इज वेरी रेयर इन नंबर. तो ये दोनों हमारे डेटा सेट में आउटलायर्स हैं, और इन दोनों आउटलायर्स के वजह से क्या हो रहा है? मेरा एवरेज बढ़ जा रहा है. राइट? माय एवरेज इज गेटिंग इंक्रीज्ड. मीन इज वेरी मच इंपैक्टेड बाय द आउटलायर्स. अगर तुम्हारे डेटा में आउटलायर्स होगा तो तुम्हारा मीन बहुत इंपैक्ट हो जाएगा. यहां पर देखो इस पिक्चर पे हम ये वाला सिनेरियो देख रहे हैं. मेजॉरिटी ऑफ द वैल्यूज आर एट द लोअर साइड, बट तुम्हारा मीन थोड़ा सा हायर साइड पे है. मोड सबसे कम है, फिर मीडियन है, फिर तुम्हारा मीन है. तुम यहां पे भी देख लो वही हो रहा है. मोड सबसे कम है, फिर मीडियन है, फिर मीन है. राइट? मीन और मीडियन और मोड दोनों सेम भी हो सकता है. बट अभी के सिनेरियो में मीन मोड सबसे कम है, फिर मीडियन है, फिर मीन है. सो मीन इज द हाइएस्ट. एंड व्हाई मीन बिकेम हाइएस्ट? बिकॉज ऑफ दीज टू गाइस, राइट? And that is what this chart is also showing, that this is the right skewed chart, which is also known as positively skewed. It is also known as right skewed, right skewed, right skewed chart, right? Where there are outliers at the higher side. Because of this, my mean increased. So mean will always impacted by the outliers, right? If there is an outlier, it will impact. That is your case number 2. Let's go to case number 3. Now, case number 3, what it says, this is my data set. Now, here, majority of the learners are getting higher marks. Only 2 learners got lower marks. Now, these are the outliers, right? These are the outliers. And what I told you, mean will impact by the outliers. अब तुम यहां देखो क्या हो रहा है, तुम्हारा मीडियन और मोड काफी बड़ा है, बट मीन छोटा हो गया है. मीन क्यों छोटा हो गया है? द रीजन इज इन दो छोटी वैल्यूज की वजह से. सो व्हेन योर मीन वैल्यू इज, sorry, when your outlier is at the lower side, my mean value will decrease. When your outlier is at the higher side, your mean value will increase. और वो वाला तुम यहाँ पे प्लॉट देख लोगे तो यहाँ पे आइडिया आ जाएगा. यहाँ पर क्या हो रहा है? When your outlier is at the lower side, or it is negatively skewed, or I can say it is left skewed, in that case lower values are lesser, and because of that your average is also reducing. And when the average is reducing, what is happening? Like when the outlier is there, average is reducing, right? That is what it is happening. Are you guys clear with this 3 picture, all of you? इसका क्लियर कट अंडरस्टैंडिंग होना बहुत जरूरी है, राइट? ये जो हमारा एक्सेल में डेटा है उसको हम लोग एक बार पाइथन में प्लॉट करके देखते हैं हाउ इट लुक्स लाइक, राइट? सो लेट मी कॉपी दिस. लेट्स गो टू पाइथन. Let's load the data, pd.read clipboard. This is my df1, and then I will be plotting sns.distplot, and I will be passing df1, right? And now when I run this, you can see थोड़ा सा ऐसा है, राइट? थोड़ा सा राइट साइड पे है, यहाँ से ऐसे जा रहा है, राइट साइड पे आउटलायर्स दिख रहे हैं, राइट? And same way, if I take the third data, which is class 3, let's plot it here. pd.read clipboard, df3, sns.distplot, df3. ये तुम्हारा थोड़ा सा लेफ्ट साइड पे हो, देखो लेफ्ट साइड पे दिख रहा है, आउटलायर इज इन द लेफ्ट साइड, राइट? सो दिस इज द सिनेरियो. ऑलवेज यू विल गेट डेटा समथिंग लाइक दिस. या तो ऐसा नॉर्मल डिस्ट्रीब्यूटेड होगा, या थोड़ा सा ये राइट पे आउटलायर्स होगा, या थोड़ा सा लेफ्ट पे आउटलायर्स होगा, राइट? इट्स अ राइट स्क्यूड चार्ट, also known as positively skewed chart, where outlier is in the right side. It's a left skewed chart, also known as the negatively skewed chart, where the outlier is in the left side. Here it's a normal data, normal distribution, or normal distributed data, where there is no outliers. Data is normally distributed, right? So that is what this particular slide is talking about. So basically, if there is an outlier, your mean will impact. If there is an outlier, your median is not impacting, right? Median एकदम सही बता रहा है. यहां देख लो, ये पिक्चर में देखो क्या हो रहा है. तुम्हारा मीन तो बहुत छोटा हो गया, बट मीडियन ठीक ठाक है. जहां मेजोरिटी है वहीं पे मीडियन आ रहा है. वेयर एवर द मेजोरिटी इज, median and mode is present almost there. यहां पर क्या हो रहा है, यहां पर आउटलायर मेरा हायर साइड पे था, तो मीन हायर साइड पे चला गया, बट मेरा मीडियन और मोड ऑलमोस्ट मेजॉरिटी जहां पर है वहीं पे दिखा रहा है। बट यहां पर क्या हो रहा है, यहां पे मेरा मीन मीडियन मोड तीनों सेम साथ में ही है, बिकॉज ये डेटा नॉर्मली डिस्ट्रीब्यूटेड है। सो बेसिकली द conclusion here is that if there is an outlier, your mean will impact. But if there is no outlier, your mean will not impact. If there is an outlier or if there is no outlier, my median will never impact, right? Median is a number which is never impacted. Either outlier is there or outlier is not there. It will never impact, right? But mean will always impact if outlier is there. And with that, let's go back to the PPT, which we have. This one. Now this will make sense. If I go to the best use case, right? Values are close together, no outliers. When the values are close together, when there are no outliers, mean is a good number. Median, there are outliers or skewed data. When there are outliers or skewed data, in that case, median is a good number. So basically, what is the idea? अगर मेरे पास डेटा में आउटलायर है और मुझे डेटा का सेंटर नंबर जानना है, मुझे डेटा का मेजर ऑफ सेंट्रल टेंडेंसी जानना है, तो मेरे पास बेस्ट ऑप्शन क्या होगा? मीडियन। अगर डेटा में आउटलायर नहीं है और उसके बाद मुझे जानना है मेजर ऑफ सेंट्रल टेंडेंसी, राइट, तो उसके लिए मैं मीन भी यूज कर सकता हूं, मैं मीडियन भी यूज कर सकता हूं। बट जहां पर आउटलायर आ जाएगा वहां पर मैं सिर्फ मीडियन ही यूज कर सकता हूं, मीन यूज नहीं कर सकता हूं, राइट। So when I want the description of a number, what is the central tendency? You have to just check it out, whether outliers is there or not. If outlier is there, go with the median as an option to understand what is the center of the values. And if outlier is not there, then I'm okay with mean or median, both. No issues. Are you guys getting this, all of you, till this point? Simple concept, but I spent a lot of time to help you understand mean, median, and mode and how it will impact, right? All right, perfect. Now, what are the problems with the central tendency, right? There are certain problems which we have with the central tendency. Let's try to understand that. Problem or limitations of measure of central tendency affected by outliers, especially mean, जो हमने डिस्कस कर लिया already, right? The mean can be heavily influenced by very high or very low values. For example, if you see this data set, right? यहाँ पर सैलरीज कैसे हैं? 25,000, 30,000, 28,000, 35,000 और एक 5 लाख है। तो 5 लाख इज एन आउटलायर। तो अगर मैं इसका एवरेज निकालूंगा तो मेरा मीन तो बहुत ही बड़ा हो जाएगा। क्यों बड़ा हो जाएगा? बिकॉज ये 5 लाख जो आ चुका है उसकी वजह से, राइट। तो वो मुझे मिस इंफॉर्मेशन दे रहा है। सेकेंड प्रॉब्लम विच वी हैव इज इट डज नॉट शो मी डेटा स्प्रेड, द वेरिएशन। All three measures tell you where the center is, but not how spread out the values are. Two data sets can have the same mean but different distribution, right? मतलब क्या? ये दो एग्जाम्पल लेते हैं, राइट। अब मैं क्या चाहता हूं, मैं तुमको बोलना चाहता हूं कि तुम मुझे इसका मीन और मीडियन निकाल के दो, राइट। See this number and give me the mean and median of both the data sets. ये लेफ्ट वाला एक क्लास है और राइट वाला एक क्लास है। तो मुझे लेफ्ट वाले का मीन और मीडियन निकालो और राइट वाले का मीन और मीडियन निकालो। पिंग मी ऑन द चैट। सपोज ऐसा मानो कि एक क्लास के मार्क्स है, राइट। एक मेरा लेफ्ट क्लास में बच्चों के मार्क्स है, एक मेरा राइट क्लास में बच्चों के मार्क्स है। सो आई वांट द मीन एंड मीडियन फॉर बोथ द डेटा सेट्स। जय, आर यू अंडरस्टैंडिंग इट? ओके। निखिल, आकाश, so by you are doing the calculation, you must have found out that the mean, median for both the data sets are same, right? दोनों के दोनों डेटा का मेरा मीन मीडियन सेम है। बट अगर मैं डेटा को देखूं तो क्या मैं बोल सकता हूं कि मेरा जो पहला वाला क्लास है उसमें सारे बच्चों के मार्क्स बहुत पास पास हैं। बट अगर मैं दूसरा वाला डेटा देखूं, क्या मैं बोल सकता हूं कि द मार्क्स फॉर द लर्नर्स फॉर दैट क्लास इज वेरी वाइडली स्प्रेड आउट, बहुत दूर दूर है। एक का -10 है, एक का 30 है, बहुत बड़ा बड़ा गैप है, राइट। इतना बड़ा गैप है दोनों के बीच में। सो द स्प्रेड इज मोर, राइट, स्प्रेड इज मोर। तो अब अगर तुम्हारा मीन और मीडियन सेम होगा दोनों डेटा में, तो मुझे तो पता ही नहीं चलेगा कि कौन सा डेटा कैसा है, बिहेवियर कैसा है, राइट। आई विल नॉट एबल टू अंडरस्टैंड स्प्रेड कैसा है। बेसिकली मुझे स्प्रेड जानना है। मुझे जो ये है क्या बोलते हैं मीन और मीडियन है, ये मुझे एक बेसिक सा सेंटर बता रहा है डेटा का, नथिंग एल्स, राइट। बट वन ऑफ द इंपॉर्टेंट इंफॉर्मेशन विच इज नोन एज स्प्रेड, वो मुझे नहीं बता रहा है, जो कि हम लोग आगे डिस्कस भी करेंगे व्हाट स्प्रेड इज। बट दैट इंफॉर्मेशन इज नॉट कमिंग इन, ओके। सो दैट इज वन लिमिटेशन विच वी हैव with the center tendency. Next problem which we have is mode may not exists or may not be unique. That is fine. Mode is what? It's a most frequent number. तो हो सकता है कि मेरे डेटा में कोई मोड ही ना हो, या हो सकता है कि मेरे डेटा में बहुत सारे मोड हो। So some data set may have no modes, all values are different. Other may have two or more than two modes, that is bimodal or multimodal data, which can be confusing. जैसे कि हमारा एग्जांपल में एक 10 था और 30 भी था, बट दोनों दूर दूर के नंबर है, राइट। तो इन दैट केस इट विल कंफ्यूज अस कि भाई क्या है, स्प्रेड कैसा है, इसका डेटा कैसा है, राइट। इट विल बी बिट ऑफ कंफ्यूजिंग। सो दैट इज वन मोर चैलेंज विच वी हैव। For example, let's try to understand this. For example, we have class 4 where we have 10, 10, 10, 10, and we have, let's say, 90, 90, 90, 90, और बीच में कुछ मार्क्स आ गए 30 and 40. Now, what is my median? My median is 35. But what is my mode? It can be 10 also, it can be 90 also, right? तो चलो हम लोग इसको 90 मान के चल लेते हैं या 10 मान के चल लेते हैं, बिकॉज इट्स अ बाई मॉडल डेटा। तो यहां तो पूरा कंफ्यूजन हो। व्हाट इज द मीन? मीन भी देख लेते हैं एक बार। एवरेज, तो एवरेज इज कमिंग आउट टू बी कितना? 47। तो ये तो पूरा मुझे कंफ्यूज कर रहा है, इट्स कंफ्यूजिंग मी, राइट। मोड बहुत ही आगे पीछे है, मीडियन एकदम सेंटर पे लग रहा है, मीन तो और ज्यादा सेंटर पे लग रहा है। तो इट्स बेसिकली बिट कंफ्यूजिंग हाउ द डेटा इज लुक इज एक्चुअली distributed. It's bit of a difficult for me to understand what's going on because it's a bimodal data. It's not making much sense to me, right? So this type of challenging situations may come. That is again one of the limitations. Mean ignores actual values. Sorry, median ignores actual values. The median only looks at the position, not value. it does not consider how large or small the other numbers are, right? वो बात भी सही है। मीडियन क्या करता है, तुम्हारा पोजीशन निकालता है, जो सेंटर पोजीशन है वो दे देता है, बट उसके आगे पीछे वाले वैल्यूज तो बड़े छोटे हो सकते हैं, बहुत बड़े भी हो सकते हैं, बहुत छोटे भी हो सकते हैं, तो उसको वो कैप्चर नहीं करता है। अगर बहुत बड़ा नंबर होगा तो कैप्चर नहीं करेगा, जो कि मीन करता है कैप्चर, बिकॉज मीन तो बढ़ जाता है अगर बड़ा नंबर होगा तो, और अगर छोटा नंबर होगा तो मीन छोटा हो जाता है। तो मीन तो कैप्चर करता है बट मीडियन कैप्चर नहीं करता है। तो मीन के कुछ बेनिफिट्स हैं, मीन के कुछ साइड इफेक्ट्स हैं, सेम वे मीडियन का भी सेम कहानी है, राइट? तो दैट इज अगेन द चैलेंज विच वी हैव। ओके, so let's take this example. Score 10, 20, 100, 200, 300. Median is 100. Score changes from 10, 20, 101, 200, 300. My median changed to 101. Even though it changed, but it is changing very small, right? तो मेरा ये नंबर हल्का सा चेंज हुआ तो वो चेंज हो गया मेरा मीडियन। इट जस्ट शोइंग मी द पोजीशन, राइट? विद द पोजीशन योर दिस थिंग इज हैपनिंग। बीच वाला मिडल वैल्यू, जस्ट दिस नंबर विल चेंज। फॉर एग्जाम्पल तुम ऐसा सोचो कि सपोज तुम्हारा ये वाला वैल्यू हो जाता है 199, तो मेरा ऑटोमेटिकली मीडियन 199 हो जाएगा, राइट? एक ही नंबर चेंज हुआ हल्का सा, और उसके वजह से मेरा मीडियन कितना ज्यादा चेंज हो गया, राइट? माई मीडियन चेंज बैडली। ओके, सो दैट इज द आइडिया। वन मोर प्रॉब्लम इज categorical data only works with mode. For example, let's say in this class, I want to know how many males and females are there. And in that, what is the mode? Mode मतलब क्या? Majority, right? Categorical data में majority. You can find the median or mean, or you can't find the mean or median of a colors, brands or names. In such cases, only the mode works, right? For example, मुझे जानना है कितने मेल्स और फीमेल्स हैं। लेट्स से 5 मेल्स हैं और 7 फीमेल्स हैं। तो मोड क्या हो गया? मोड हो गया फीमेल्स, राइट? बिकॉज मोड इज मेजोरिटी एंड मेजोरिटी आर फीमेल्स। बट आई कैन नॉट टेक द एवरेज, राइट? मेल प्लस फीमेल डिवाइड बाय 2 क्या होता है? आई कैन नॉट डू द एवरेज। So for any categorical data, I can only get the mode. For example, let's say I have learners from different states. Let's say 5 learners from Gujarat, 2 learners from Haryana, 1 learner from MP, and one learner from Maharashtra. So what is the mode? Gujarat is the mode because majority is coming from Gujarat, right? So that is what we can do maximum with the categorical data. मैं categorical data में average नहीं निकाल सकता, right? So that is one thing. Now different measures give different answers. वो भी हमने चेक कर लिया था, राइट? मीन अलग है, मीडियन अलग है, सब कुछ अलग अलग दिखता है, राइट? मीन कभी अलग दिखा देता है वैल्यूज, मीडियन अलग वैल्यू दिखाता है, आउटलायर होगा तो अलग तरीके से बिहेव करेगा, मोड में अगर मल्टी मॉडल डेटा होगा तो अलग बिहेव करेगा, मीडियन तुम्हारा हल्का सा वैल्यू मिडल वैल्यू चेंज होगा तो मीडियन पूरा अजीब सा दिखेगा, राइट? सो इट्स लाइक लॉट ऑफ चेंजेस आर हैपनिंग, सो डिफरेंट मेजर्स गिव डिफरेंट आंसर्स. So bit of a tricky thing, right? Which we have. Bit of a tricky thing which we have. So these are the limitations which we have in our measure of central tendency. Okay. So conclusion, no single measure of central tendency works perfectly in all situations. Best practice, use mean and median and mode together, and also consider spread like standard deviation or range to understand the full story, right? As of now, we did not discuss about the standard deviation and range, but we understood mean, median, and mode for now. So till this point, what we have discussed, that what is mean, median, and mode, and what are the limitations of it, and what are the benefits of it. Where can we use mean, median, and mode? All those things we have discussed. Here is the summary of that. Problems of measure of central tendency affected by extreme values, that is outliers. The mean can be heavily influenced by very high or very low values. Doesn't show data spread. It will not help me understand the spread the way we have seen this example, right? This example. In the class 1, we have all the values more nearer. In the class 2, we have all the values very farther. So it's not talking about that. My median and mean both are coming same. So that is the second problem. Third is mode may not exist or may not be unique. Right? I may have a data with no mode, or I may have a data with multi-mode. That is one problem. Next is different measures give different answers, right? Mean, median, mode can disagree, right? Mean, median, mode can disagree. So that is again one problem which we have. So that summarizes your measure of central tendency. Now what we'll do, we'll try to solve this. I'll give you certain questions. Now I want you to play around with that and I want you to tell me the answer. Okay. So here is the first question which you have to solve and I want you guys to ping me the answer. Retail industry sales impact. A retail chain is analyzing weekly sales in thousands across different 8 stores. Each store has different sales ranging from 8,000 to 1,50,000. They open a flagship store and flagship store with 9 lakh weekly sales. Right? So basically a new store coming in with a weekly sales of 9 lakh. How does opening this flagship store affect the mean and median of weekly sales? What do you think? Which option is correct? Lakshya saying option C. I think that is wrong. Option A. That is wrong as well. Option B. Option B is correct. So the correct answer is option number B. Why option number B is correct? Let's try to understand. As of now, this is my data. A new store comes in. Let's say store I. What is the sales there? 9 lakh. Right? What was the earlier median? इसको हटा दो अभी के लिए. पहले मीडियन क्या था? 1 2 3 4 5 6 7 8. So 1 2 3 4 5 इन दोनों का एवरेज. Right? That was the earlier median. That is 18 plus 25 divided by 2. How much it is? पहले की बात कर रहा हूं जब ये डेटा नहीं था. तो था इसका एवरेज कितना होगा? 25 35 45 45 में से 2 गया 43 43 by 2 22.1, 22.5, right? 22.5. 21.5, that's fine. Okay, 21.5. So that was my median. What was the average? This plus 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 this by 8. 1, 2, 3, 4, 5, 6, 7, 8. करो एक बार इसको. 8 plus 10 plus 12 plus 18 plus 25 plus 30 plus 45 plus 150 divided by 8. 37.25. So 37.25 is my mean. Okay. Now, जब ये नया वाला डेटा आ गया, अब मेरा मीडियन क्या होगा? Now we have 9 values. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5. My new median, now my new median is 25, right? So earlier median was 21.5 and now the new median is 25. So my median increased. That's fine. Median increased. Okay, median increased. What about mean? 900 plus 298, right? 298 plus 900 divided by 9. 133. Earlier my mean was 37.25. Now it is 133. It increased drastically. What is the option number B? Both mean and median will increase, but mean increases more. Are you guys understanding this, all of you? Why option number B is correct? Okay. All right. Let's take one more. Tell me the answer. Transportation industry, vehicle maintenance costs. A logistics company tracks annual maintenance cost in thousands of 8 trucks. They add an old truck with a maintenance cost of 2 lakh. That is 200 basically, right? 2 lakh means 200. 3 zeros you can cancel, so 200 is coming in. Okay. So I have a 9th truck with maintenance cost of 200. How does the addition affect the average and the median maintenance cost? Only the median will increase, both mean and median will increase, but mean increases more, median decreases, median stays the same, both mean and median increases equally. अब इतना टाइम लगना नहीं चाहिए. देखो तुम सारा मैनुअली कैलकुलेट मत करो, राइट? Just see, as of now, the values are in 20s and 40s. The new value is coming in 200. That means एक outlier आ गया. Outlier आ गया, वो भी बड़े साइड में आ गया. मतलब कि मीडियन मेरा बहुत ज्यादा इंपैक्ट करने वाला है. मीन मेरा, सॉरी, मेरा मीन ज्यादा इंपैक्ट करने वाला है, मीडियन कम इंपैक्ट करने वाला है, राइट? तो ऑटोमेटिकली मेरा ऑप्शन नंबर सी हो जाएगा, सॉरी ऑप्शन नंबर बी हो जाएगा, राइट? सो बी इज द करेक्ट आंसर. So whenever you are getting this type of questions, you just see that outlier coming in, yes, higher or lower side, let's say higher side. So automatically it will impact the mean at the higher side. Median may not impact much. Okay. So that is how you have to quickly answer. Don't spend time on the calculations. Let me know about this. A bank tracks loan sizes in lakhs of 8 customers. A high net worth customer takes a 25 lakh loan. Earlier, people were taking less loan, but now a big guy came in and he took 25 lakhs of loan. Now what will happen with the mean and median? Option number B is the correct answer because mean increases sharply, median increases slightly, right? So again, the B is the correct option. Tell me about this. This can be a bit, you have to check from your side. Option number B, right? Mean will increase, mean will increase more than median. Right? Option number B. Because a bigger value come in. It's not an outlier though, but yes, my mean will increase a bit. And my median will also increase a bit. Here also option number B only looks like, right? Because outlier came in 150 minutes. My mean will increase, median will be almost the same. All right. So that is about your mean, median, and mode. And I hope you guys got the understanding about what it means, what is the purpose of the same. Now we'll talk about another measure of thing, which is measure of spread, right? We got the problem with the mean, and now we'll try to understand what can be the solution, right? Because in a descriptive statistics, the biggest thing which I am interested in is I should get as much information I can get from my data set. That is what I'm looking for. So measure of spread. When we use measure of central tendency like mean, median, or mode, we find the center of data. But just knowing the center is not enough. Measures of spread tells us how much the data is scattered or spread out around that center. It answers questions like, are all values close to the average? Or are some values way too high or too low, right? It gives me understanding about how the spread is. Let's take an understanding of the same. There are various measures of spread we have. One is range, second is interquartile range, third is variance, fourth is standard deviation, and fifth is MAD, mean absolute deviation. Today we'll cover few of them. First of all, why it is important? Let's say two students both have an average score of 80. But one scored 79, 80, and 81. And the other scored 50, 80, and 110. Basically, there are two students and they gave three exams. So one learner in his first exam got 79. In the second exam, he got 80. And in the third exam, he got 81. Second learner, he got 50 in the first exam, 80 in the second exam, and 110 in the third exam. So if you see in the first student's marks, the marks are very closely aligned, right? Values are very close. But if you see the second learner, the marks is very much spread out. But if you see the average or median, it's 80, right? So that's why we need a measures of spread to know how consistent or the variable the data is. How much data is varying. अगर तुम देखोगे 79, 80 और 81, उस बंदे ने ज्यादा अच्छा काम नहीं किया है, वो ऑलमोस्ट उसी रेंज में घूम रहा है. बट अगर तुम दूसरा बंदा देखोगे, दैट इज योर 50, 80 एंड 110, तो वहां पे तुम्हें क्या दिख रहा है? वहां पर वो बंदा काफी इंप्रूव करते हुए दिख रहा है, राइट? द रेंज इज बिकमिंग क्वाइट बिगर. So I can clearly say that student number 2 is doing good as compared to student number 1 over the period of time. But how will I get to know that? अभी तो 3 ही records हैं, तो सब ठीक लग रहा है. But what if when the data volume is high? In that case, it's difficult for me to understand that. So that's why we need one more measure, which is known as measure of spread. So let's try to understand this. The first measure of spread, which is we are going to use. Normally, we are not using this quite extensively, but yes, this is one of the measures which we have, known as range, right? Definition of the range is nothing but difference between the highest and the lowest, right? Difference between the highest and the lowest. For example, if you see the score 70, 75, 80, 85, and 90. So what is the range? The range is nothing but bigger value, that is 90, minus the smaller value, that is 70. So 90 minus 70 is 20. If you see in the picture in the right side, here I have a lot of people with different, let's say, marks. So this is the highest marks. This is the lowest marks. So the difference between the highest marks and the lowest marks is known as range, right? So simple, but does not show what's happening in the middle. It is simple measure, but it's not giving me a better understanding about what's going on in the middle. But the formula is maximum minus minimum. That is my range, right? It's a simple measure of spread, which is just subtracting the highest value minus the lowest value. Second is your interquartile range, right? Interquartile range is what? To understand the interquartile range, we have to understand some plot out here. This I will discuss maybe in the tomorrow's class because we require some of the understanding. So we'll skip this for some time. Or let's do one thing. Let's complete this only. We'll spend time on this and we'll end the session. Okay. So interquartile range, which is also known as IQR, right? IQR is basically nothing but interquartile range. What it means? Range of the middle 50% of the data. Between 25th and the 75th percentile, right? What is 25th percentile? What is 70th percentile? We'll discuss that. Removes extreme values, that is outliers. So it gives a more stable view. Interquartile range is nothing but Q3 minus Q1, right? So a lot of technical things coming in. Let's try to understand. Here you can see the picture as well. We'll discuss about this picture later on. But first, let's try to understand what interquartile range is. Here is my data set. Okay. Where I have the age of my learners. 4 years, 23 years, 24 years, 24 years, 26 years, 26 years, and 60 years. Now, my question to you guys is, what is the median of this particular data set? All of you. 24, perfect, right? There are 1, 2, 3, 4, 5, 6, 7 values are there. So my median is 24. If you see this particular box is known as box plot. We will be discussing that more in detail later on. But this particular box plot, this particular chart is known as box plot. Okay. Now this black line which you can see, this black line denotes your median, right? This black line denotes your median. So here you can see that my median is nothing but 24. Another name of 24 is, or another name of median is quartile 2, right? That is what we have. Now, ignore this number. Ignore this number. Focus on these three numbers. What is the median of these three numbers? All of you. 23. What is the median of these three numbers? 26. Right? So, the start of the box is nothing but this median. End of the box is nothing but this median. Right? The lower median is my start of the box, which is also known as quartile 1. Higher median, which is end of the box, it is also known as quartile 3. Quartile 1 minus quartile 3 is known as interquartile range, right? Quartile 1 minus quartile 3 is known as interquartile range. Right? Bigger the spread is, bigger the quartile range will be. Try to understand this. Let me go to Excel file and let me get some data here. Right? Let's say I have marks 10, maybe 30, 50, 80, 100. Right? This is my marks. And let's say I have another class where the marks is 10, 12, 14, 16, and 18. Okay. What I told you, bigger the spread is. Here the spread is more, right? 100 is the highest value, 10 is the lowest value. Spread is more. Here the spread is less. 10 is the lowest value, 18 is the highest value. Spread is less. Let me calculate the IQR for this data set, right? For that, I have one option here, which is known as quartile. Quartile. What is Q1? Q1 is nothing but 0. Or I have to pass the array. I have to pass this array, comma 0.25, right? Q1 is nothing but 0.25 quartile. That is 30. And quartile of this data set. And I am looking for what? I am looking for third quartile, 75th percentile. Right? And now I will calculate the difference. That is Q3 minus Q1. My IQR is coming out to be 50. Let's go to this example. I will calculate the quartile, that is 25th percentile. That is my quartile number 1. And I have a quartile which is the 75th percentile. That is nothing but quartile number 3. And if you see the difference is coming out to be 4. Here the spread is more, automatically my quartile is increased. Here the spread is less, automatically my quartile is decreased. Right? Are you guys understanding this? How this interquartile range is helping you understand how the spread is, right? All right. Now, this particular example which I talked about, is for the odd numbers, right? We had 1, 2, 3, 4, 5, 6, 7. 7 numbers are there. But what if we have even numbers, right? What if we have even numbers? In that case, how this Q3, Q1 gets calculated? Let's try to understand this. Let's say I have another data set, which is 4, 23, 24, 24, 26, 24, 24. Let's add one more number, 25, 26, 26, 60, 26, 60. Now, how many numbers we have? 1, 2, 3, 4, 5, 6, 7, 8 numbers are there, right? First of all, I want to calculate my Q2, which is also known as median. So median will be what? Median will be middle two numbers average. That is 24.5. So I got my Q2, right? I got my Q2. Now, I want to calculate my Q1. In this example, as we are having even numbers, I will take this 24 for calculating my above median. And same way, for calculating this below median, I will be going ahead and taking this number. So what is the median of above part? 23.5. What is the median of below part? 26. So what is my IQR? 26 minus 23.5. Are you guys getting this, all of you? When we have the even number of records, how we calculate the interquartile range, right? And that is what I have shown in this picture as well. If you go back to that animated picture, here you can see, right? This is my, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 records are there. So this middle value is my median. I am ignoring this part. Now I am calculating the median of this part. This is the median. I am calculating the median of this part. This is the median. So Q1, Q3. But when we are having even numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In that case, middle two value is my median average. Now I will be considering this record for above calculation of median. 1, 2, 3, 4, 5, this value. And I will be taking this record for this median calculation. 1, 2, 3, 4, 5, this value. Are you guys getting this picture, all of you? Okay. So that is your interquartile range. Interquartile range is basically nothing but helping me understand about how my this thing spread is, right? How my spread is. So we have discussed two measure of spread. One is your what do you say, range, and second is your interquartile range. Range is nothing but maximum value minus the minimum value. Interquartile range is nothing but you are calculating the upper median minus the lower median. First of all, you are calculating the main median, then upper median and lower median. Right? Okay. So that is the whole story. All right. So this is about your interquartile range, and we discussed about, as of now, I discussed about few part of this plot, how to calculate the IQR. There are few more things available in this plot, which I will be discussing later on. Right. So wait for some time for this. Now, the next we have is variance. Now, what I will be doing is I'll explain this briefly, right? We'll talk about this more in detail in tomorrow's class. But as of now, let's understand briefly about this. Variance is nothing but it shows how much the number deviate from the mean, right? If you see below pictures, in the left chart, you can see the values are more closer, and as the values are more closer with the mean, right? If you see this purple color, it's my mean. And you can see all the values are very closer to the mean, right? All the values are very, if you see the lower value also, it is very closer to the mean. And the higher value also very closer to the mean. So values are more closer to the mean, right? That means the values are more closely coupled, right? Very much closely together. But here you can see that this is my mean. So my lower value is very far and my higher value is also very far, right? So automatically the gap is more. Variance is one of the measures which calculates that gap, distance from the mean. You can see how the numbers are deviate from the mean, right? How far I am from the mean. If the values are more far from the mean, automatically the variance will increase. If the values are lesser far from the mean, automatically the variance will decrease. In this particular example, my variance will be less. In this particular example, my variance will be high. Because here I am having the values which are very far or spread out from the mean. Here the values are not that much spread out from the mean. Okay. This is the formula for the variance. There are two different types of formulas are there, which again we will be discussing more in detail in the tomorrow's class. Tomorrow class will be basically on these concepts only, where we will be discussing about how this variance gets calculated and at the same time what it denotes and why there are two different types of formulas. I can see one formula which is the population formula. I can see one formula which is the variance formula. Sorry, sample formula. So why we are having two formulas, right? We'll discuss about that. Same way, there is another measure which we have, which is the standard deviation. Standard deviation is actually nothing but the square root of variance. If you see, the variance is in the power of 2. It's a square. But if you see the standard deviation, it is the square root of that power, right? It's at the power of 2. Uska square root is my standard deviation. तो जो भी वेरिएंस आ रहा है उसका अगर तुमने स्क्वायर रूट कर लिया तो वो स्टैंडर्ड डेविएशन कहलाया जाएगा. स्टैंडर्ड डेविएशन के भी दो फॉर्मूलाज हैं, एक पॉपुलेशन का है और एक सैंपल का है. तो फॉर्मूला अलग क्यों है वो हम जानेंगे कल, राइट? अब अलग क्यों है उसका रीजन हम लोग जानेंगे, राइट? विच इज नोन एज बेशेल्स करेक्शन. सो विल टॉक अबाउट दैट and all those things we'll see. Okay, so that is the agenda for tomorrow's class. Let's quickly talk about what we have discussed today. We had a discussion about statistics, the different types of statistics. I told you that we are focusing on the descriptive statistics as of now. Whatever data we get, we want to try and get the understanding of that data, try to get some relevant information from that data. So we talked about the measure of central tendency, but before that we talked about the different types of data which we have, that is qualitative and quantitative data. Qualitative data is also known as dimensions or categorical data. Quantitative data is also known as numerical or measures or facts. Qualitative data is basically are of three types: nominal, ordinal, and Boolean. Nominal is basically nothing but a proper category like male, female, states, and so on so forth, where I cannot apply a rank. I cannot say that male is bigger than female or female is bigger than male, right? So it's a pure category. Second is ordinal data, where we have the order. You are giving the feedback to this class. It can be poor, average, good, and excellent. So it has an order. Poor is lesser than average, average is lesser than good, good is lesser than excellent. So that is one example. Boolean is like true and false, right? Where I can say whether I'm graduate or not. So it will be like true and false or yes or no. That is Boolean. Quantitative is more like number. Discrete is number without decimal. Continuous is number with decimal, right? We talked about descriptive statistics. In that we had mean, median, and mode. Mean is impacted by the outliers. Median is not impacted by the outliers. Mode can have the data in the mode, like mode can be there in the data or it cannot be. We can have multiple modes as well, right? That is also possible. This is the formula which we have discussed. 1 upon n into summation of xi, that is summation of all the records by number of records, that is my mean. Basically, again, also known as 50th percentile. And if there are even number of records, then we go with n by 2 plus n by 2 plus 1 by 2. That is nothing but, let's say if I am having 8 records, so fourth record plus fifth record by 2, that is the formula. N is nothing but total number of records. For median, for odd numbers, we have n plus 1 by 2. Let's say we have 9 values. So 9 plus 1 is 10. 10 by 2 is 5. So fifth value is my median. Okay. Then mode is the most frequent number. It can be like no mode data also available. Bimodal data is also available. One modal data is also available, which is a unimodal, and trimodal data or multimodal data can also be available, right? That is what we discussed. When to use what? If there is no outliers, we are good to go with mean. If there is an outlier, we can go with median. Mode, mostly we can use with the categorical data. For example, how many males and females are there? If let's say there are more females, so I can say that the mode is female, right? We cannot apply mean or median on the categorical data. Here is the picture which we have discussed, that how the mean is getting impacted by the outliers. If the outlier is at the lower side, mean will be going to the lower side. Median is not impacting much and mode is also not impacting much. If outlier is at the higher side, mean will also go towards the higher side. Median and mode will not impact much. When the data is normal distributed, in that case, mean, median, mode, all are on the same lines. We discussed about some of the challenges with the central tendency, that is affected by the outliers, does not show proper data spread. Um, we took this example and we understood that what is the problem with this. Then we had a discussion about mode is sometimes may exist, sometimes may not exist. Median ignores the actual values. It is actually working with the position of the data, right? Middle value. So if your middle value changes drastically, automatically your median will also changes drastically. Then categorical data, we can only work with mode. We cannot use your median or mean for categorical data. Different measures sometimes gives you different responses. That will also confuse us, right? So that was the challenges. That's why we decided that, okay, with mean, median, mode, let's talk about measure of spread as well, because that will give me some additional information also. Here is the discussion about what we have. We solved certain quizzes and then we talked about the measure of spread. We have different types of measure of spread. That is your range, your interquartile range. Range is nothing but your maximum value minus minimum value, right? It's a simple measure. Normally, we are not using this quite extensively, but it is the simple measure of spread. Second measure of spread is your interquartile range, where we are finding the median, the main data median. After that, we are finding the median for the upper part, median for the lower part. Upper part median is known as Q1. Lower part median is known as Q3. Subtraction of Q3 minus Q1 is known as interquartile range. For calculating the interquartile range, the behavior is different for even number of records and for odd number of records. For even number of records, what we do is we find the median of the middle two values, and then those middle two values will also be participated for calculating the lower and the upper median as well. However, in the odd number of records, we are calculating the median of the data, which is middle value, and we ignore that record and calculate the lower median and the higher median by ignoring that record, right? That is how it works. That is what we discussed, and then we ended the session. Basically, we will start the next measure, which is measure of spread, in the next class, right? So that is the entire thing which we have discussed. Any doubts you have, let me know. Are you guys feeling comfortable with all these things which we have discussed? I hope it gave you the quick revision as well, that what it is and how it is. All right. So we'll proceed further in tomorrow's class, where we'll be starting with the measure of spread, which is variance and standard deviation. Those are the two measure of spreads which we are using quite extensively, right? So that's why I wanted a fresh mind. We'll start with the fresh mind and we'll understand what it is. Because these two terms you are going to listen in the data analytics and data science world quite extensively. Okay. I have a doubt in LOD. You can email me. I'll discuss over the email. In this class, any doubt, you can let me. Or you can ask me to connect. We can connect offline on Monday. Alright, so we'll see you in the next class. Till then, take care. Have a nice day and good night.